Hello, in this video, I will explain to you on how to solve this problem. Let's read the problem first. An 8-kilogram block of ice released from the rest at the top of the 1.30-meter long frictionless ramp. Okay, and it slides downhill, reaching a speed of 2.59 meter per second at the bottom. Okay, maybe let's draw the situation first. So we have a hill here, which is frictionless. Okay, and then we have the ice, which is 8 kilogram here. So it has the mass m here, which m is 8 kilogram, right? And then it has 1.31 meter long. So we will have that ram is 1.31 meter long. Okay, and then the speed at the bottom here, so the speed here v, that will be 2.59, and this is the final velocity, but then it is released from the rest, so the VO here will be 0, right? 0, and the unit here will be meter over second, and this one also meter over second. And we can use kinematics to calculate the acceleration, right? Because this is the length. We know the length, we know the initial velocity, we know the final velocity. So we will have here, using kinematics, Vt squared, and then that will equal to Vo squared plus 2ax, right? So I'll have 2ax. Okay, but what is Vt squared? I will have 2.59, and then this will equal to, we will have 0 squared and then plus 2. Okay, now the acceleration here, because we don't push any force here, the only force that work on this ice is its weight, right? So I will have the force by the weight. However, if we have theta here, so we will have the acceleration pushing there, here is theta, right? But then because we don't have any force pushing this here, the acceleration here is g, but the direction is g sine theta. So I'll have g sine theta here, right? And then we will have x, which is 1.31. Okay, and we need to find out what is theta, right? So let's just calculate that. So we will have 2.59 squared, and that will be 6.7081, 6.7081, and then 0 squared, we can just leave it as is, and then 2 multiplied by 9.8, and then multiplied by 1.31 and sine theta. And I think we can just isolate for sine theta here. So sine theta here is equal to 6.7081 and then divided by 2 multiplied by 9.8 and then multiplied by 1.31. So I will have our sine theta that will equal to 6.7081 and then divided by 2 multiplied by 9.8 and then multiplied by 1.31. Okay, and so I'll have 0.261, 261. But then here we can calculate what is theta, right? So that will be the inverse of sine, 0.261. And I will have 15.13 degrees. 15.13 degrees here, and that is the answer for question A. Good. And now let's move on to question B. Okay, now let's move on to question B. What would the speed of the ice at the bottom if the motion were opposed by a constant friction force of 10 Newton parallel to the surface of the ramp? So we introduce a new force here, which is 10 Newton friction force. So I will have this opposing here. So I will have the force of the friction, and that will be 10 Newton, right? But then we have the forward force there. So we will have F by the weight here sine theta, right? And because the motion goes there here, let's do that. So I will have sigma F here. So I have sigma F that will equal to the mass times acceleration. Okay, so here we have Fw sine theta on the direction of movements. And that will be opposed by the force of the friction, which is Ff. And that will equal to the mass times acceleration. We are looking for the acceleration here. Okay, now the force by the weight here. So we will have 8 kilogram multiplied by 9.8, right? That is the weight of the ice. And then sine, what is theta? I will have 15.13 degrees. Good. And then we have the opposing force of 10 Newton. So I'll have 10. And that will equal to 8 times the acceleration. Good. Now let's plug that in on the left hand side. So we'll have 8 multiplied by 9.8 and then sine 15.13 and then minus 10 here. So on the left hand side I will have 10.46. 10.46 here. And on the, do I have? Yes, okay. So on the right hand side, I will have 8. So the acceleration here is just this number divided by 8, right? So this number divided by 8. So I will have 1.31. So I have 1.31 meter over second. Good. But then that is not the question is asking. We are asking for the speed here. The speed Vt. So we need to do kinematics here. Okay, and to do kinematics, we need to use this one. Vt squared, that will equal to Vo squared, and then plus 2ax, right? So we can just calculate Vt squared here. Vt squared is just, because it starts from the rest, and we don't apply any push here, so I'll have 0 squared, and then plus 2, and then what is the acceleration? I will have 1.31 here. Okay, and then what is the x? 1.31. Oh, nice coincidence. So we will have Vt squared here is equal to, I think we will have 2.1,31 and then times 1.31. Okay, I will have 3.4322. 3.4322. But then this will be our Vt. We take the square root of this number. So the square root of this number, and that will be 1.85. Okay, so we have 1.85, and the unit here will be meter over second. So the angle of the ramp is 15.13, and then the speed when it has 10 Newton friction is 1.85. Okay, thank you for watching and see you in the next video. Bye bye.